The Leave plan of space experts has found that utilizing our new $10 billion toy, it will be years before that undertaking turns into a reality. On the off chance that it goes as planned, the excursion to Proxima B will take around 20 years. So, reasonably, it will be quite a few years before we can affirm if there is, to be sure, life on that planet. The age-old inquiry of whether we are genuinely alone in this universe endures. The James Webb Telescope has found some frighteningly humanesque things far away from Earth that lead us closer to the response. Our quest for life outside of us has been uncontrolled throughout each human civilization, to such an extent that we have a great many media, writings, and hypotheses regarding this matter. Our marvel in regards to our place and loneliness in the universe has been constant, as though it is instilled within us to constantly look for a buddy, no matter how outsider-like we may be. We may be getting increasingly close to the answers we genuinely need, but are they genuinely the answers we are searching for, or are they significantly more startling? Join us as we investigate the latest revelation in the domains of systems and planets on the journey to track down something we probably won't be ready to observe. Light's a long ways off. Researchers have found what could be the most momentous discovery in history. Back in 2021, when the James Webb Space Telescope was scheduled to launch, a very interesting theoretical inquiry was raised about the capabilities of our technology. The question was whether, in the future, our telescopes could identify artificial light on another planet, such as Proxima B, the nearest exoplanet to Earth. Proxima B, around 4.25 light-years away, was accepted to be perfectly locked with a permanent dayside and night side, like our Moon. A theoretical technological development on Proxima B could move intensity and power from the dayside to the night side using photovoltaic cells that create power from starlight. Accordingly, in a paper with Manas V. Lingam as one of the scientists, it was shown that huge inclusion of the dayside by solar chargers could be identified with future telescopes. Since JWST was more advanced, it would allow us to expand our search for artificial lights on livable exoplanets like Proxima B. Now, the fact that the James Webb Space Telescope did just that in 2024, utilizing its higher awareness and greater range of abilities, is groundbreaking. The JWST could have found the lights we were looking for and conceivably heaved us into another huge wave of human advancement. Above all, let's dive into the universe of planets and exoplanets to figure out how this was indeed even conceivable. James Webb's mission investigates Proxima B and Peak B's secrets. Since forever ago, humans have pondered about the concept of the universe. What we are, where we come from, and where we go. These are normal yet incredibly difficult questions that humanity has attempted to answer. When we gained awareness in the period of outstanding mechanical progression, one wonders whether we are any closer to addressing these inquiries. If you were to ask a philosopher, he could say we are still at level 0 of understanding ourselves in the universe. However, ask a space expert exactly the same thing and watch him jump all over in excitement as he races to tell you the latest discovery people have made about the universe using their clever devices. These instruments, although not given much consideration by the typical public, are directly a reflection of human advancement itself. We now have the world at our fingertips, and it's time we push ahead and get the universe at our fingertips, too. One such method for doing that has been derived by researchers and astronomers through the technology we tackle. A particular making of that technology is now responsible for the new discovery of what may be light on an alternate planet light-years away. Yes, we're talking about the James Webb Space Telescope. The James Webb Space Telescope is the creation conceived out of the legacies of human endeavors into space to answer some ever-present questions. Are we only who's out there? Where do we start and where do we end? This infrared space science device has already started addressing these inquiries. Despite the fact that at first you might get yourself asking what Proxima B is, Proxima Centauri B or just Proxima B is sometimes referred to as Alpha Centauri C. It is a super-Earth exoplanet and orbits an M-type star. Super-Earths could confuse you, but don't worry. This text will settle all your burning questions. Super-Earths are a class of planets that are more massive than Earth but lighter than ice giants like Neptune and Uranus. They are really one of a kind. They can be comprised of gas, rock, or even a mix of both, and their sizes can differ from twice the size of Earth to 10 times its mass. They truly put the super in Super-Earth. Regarding Proxima B, it is a super-Earth and an exoplanet, meaning that a planet orbits outside the nearby solar system. The first possible evidence of an exoplanet was seen as early as 1917, although it generated little interest and acknowledgement. However, in 1992, the first confirmed detection occurred, which left researchers astounded. Another exoplanet, first identified in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Out of these, 896 systems have more than one planet. These superb discoveries are circling an M-type star. To understand the M-type star, you need to figure out the red dwarf. A red dwarf is the smallest type of star in the main sequence, hence the name. In the adjoining sectors of the Sun, red dwarfs are by far the most common type of star to be found in the Milky Way. They have very low luminosity, and since luminosity is one of our main tools for planet location and other kinds of allowances, red dwarfs are not so easy to notice. These subtle stars have variable definitions and names depending on their temperatures and sizes. For example, M-dwarfs or M-type main sequence stars yield a maximum temperature of around 3000 K, hence getting their name and attributes. Returning to Proxima B, its mass is known to be equivalent to 1.07 Earths. Curiously, it only takes 11.2 days to complete one orbit of its star, compared to our 365.25 days. You can estimate the size of the star Proxima B is circling, stunningly under the estimation of the whole electromagnetic spectrum. The star has a total luminosity of as little as about 1.6% that of the Sun. Furthermore, in the visible light range, its luminosity seems to dull significantly more. It only shines 5 to 6% of the Sun's luminosity in the visible light range, transmitting a considerably lesser amount of light energy compared to the Sun. More than 85% of its produced energy is in the form of infrared radiation, circling about 0.045 to 0.056 Australian dollars from its star. Proxima B's discovery was announced back in 2016. You may wonder why Proxima B, with millions of stars, planets, and galaxies, why are we so focused on this particular celestial body? Well, there are a couple of reasons that add to the distinct fascination astronomers have in this place. First and foremost, Proxima B is the closest known star to our Sun, and by definition, although 4.2 light-years is a big number to us Earthlings, in the grand scheme of the universe it is a mere blip. Hence why Proxima B, our nearest known star, is high up on the priority list. At the moment, it is also part of the triple star system called Alpha Centauri. Moreover, although Proxima's luminosity is very low, the system itself appears as one of the brightest celestial bodies in the night sky, just behind two others, called Sirius and Canopus. However, the most intriguing thing about Proxima Centauri B is that it could possibly be habitable, as it falls within the habitable zone. The possible outcomes surrounding the star are endless, and therefore, astronomers have taken on the task to explore the depths and limits of the star's potential. That's where the James Webb Space Telescope comes in. The 4 key objectives of the JWST are to look for light from the first stars and galaxies that formed in the universe after the Big Bang, study galaxy formation and evolution, figure out star and planet formation, and concentrate on planetary systems and the origins of life. As the JWST continues its investigation of the said exoplanet, we get closer to the culmination of these missions, from looking for exoplanets to looking for alien life. So, what exactly is said, one could inquire? Considering that humans have always been a curious species, probing and goading into literally everything that moves and doesn't move, it makes sense that a mission like SETI came into existence on such a massive scale. Imagine that God has organized a grand cosmic expedition, but with a twist of gold. We are entrusted with being on the lookout for signals. More specifically, electromagnetic whispers from civilizations beyond anything we could ever imagine. SETI, short for the search for extraterrestrial intelligence, is like the world's most high-stakes game of hide-and-seek, with our planet as the searcher and the vast universe as the seemingly endless hiding spot. It is one of those fields where scientists are advanced Sherlocks, tuned into radio waves and scouring for that subtle, we are not alone moment. This astronomical snooping started vigorously in the 1960s. Frank Drake, a noted astrophysicist, was the first to design and launch the radio telescope search. He proposed that the search for aliens could be narrowed by recognizing artificial radio signals, possibly from advanced civilizations. A huge milestone was achieved by detecting the first artificial signals, which turned out to be radio signals from Earth itself. This very detection set the course for groundbreaking developments, pushing the envelope on how we search for intelligent life. As technology continues to improve, the idea that we can detect artificial lights, or even the electromagnetic signals themselves, is becoming more plausible. The fact that we might be detecting these elusive, extraordinary signals brings us ever closer to answering the question that has baffled humanity for generations. Are we alone? As we continue to refine our technological capabilities, the detection of artificial signals from distant planets becomes less of a hypothetical scenario and more of a reality. The James Webb Space Telescope, JWST, and other instruments, like the upcoming Extremely Large Telescope, ELT, are equipped with advanced technologies that can detect faint electromagnetic signals or artificial light emanating from exoplanets, especially those within habitable zones. These instruments are designed to capture light in various wavelengths, particularly infrared, which is where many potentially habitable planets shine. If these telescopes can identify artificial light or anomalous signals from these distant planets, it could mark the beginning of a new era in astrobiology, the discovery of extraterrestrial civilizations. One of the most profound challenges we face in this search is the vastness of space. Despite our most advanced telescopes, the distances involved are immense. Proxima B, as an example, is over 4 light-years away, which means that even if it were an ideal candidate for harboring life, any signals we might detect today would have traveled for years to reach us. This delay presents not only a challenge in terms of the time it takes for us to gather data, but also in terms of how we interpret these signals. What we discover in the next few decades could very well be a glimpse into the distant past of another civilization, one that might not even exist by the time we receive the message. Yet, the possibility that we might someday receive a clear, unmistakable signal from Proxima B or another exoplanet is something that keeps scientists up at night. Imagine, for a moment, what it would mean for humanity if we were to confirm that life, intelligent life, exists somewhere beyond our planet. The implications would be profound, not just for science, but for philosophy, theology, and even our sense of purpose. Would it change the way we view our place in the universe? Would it affect our understanding of life, death, and our role on Earth? These are questions that researchers, thinkers, and dreamers have pondered for centuries. Moreover, the discovery of artificial light or signals from another world would not only be a triumph of technology, but also a reflection of the human spirit, our insatiable curiosity, our drive to explore the unknown, and our desire to connect with something greater than ourselves. This search for life in the cosmos speaks to something deeply human: the need to understand, to discover, and to belong. The next few decades will be pivotal in this search. With advancements in both ground-based and space-based telescopes, we are on the brink of discovering more about the conditions that make planets like Proxima B habitable. Additionally, scientists are continuing to refine their search methods, using techniques like spectroscopy to analyze the atmosphere of distant exoplanets and look for signs of life, such as oxygen, methane, or even artificial chemicals. However, detecting life or signs of it on another planet doesn't just depend on technology. It also requires us to rethink our definitions of what constitutes life. While we typically think of life in terms of carbon-based organisms, the possibility exists that alien life could be radically different from anything we can imagine. Researchers are exploring alternative biochemistries, such as life that could exist in extreme environments or that might rely on different building blocks, like silicon instead of carbon. In this context, even if we do detect signals from distant planets, it might take us some time to understand whether those signals are truly from an alien civilization or merely natural phenomena. As we continue to push the boundaries of what is possible, the collaboration between international space agencies, private companies, and scientific institutions will be crucial. The future of space exploration, especially in the context of astrobiology, requires collective effort and a willingness to embrace the unknown. Whether it's through the search for biosignatures, the detection of artificial light, or the decoding of potential signals, the journey to find life beyond Earth is one that will define the next era of human discovery. In conclusion, while the prospect of finding life on another planet remains elusive, The technologies being developed and the questions being raised are already changing our understanding of the universe. The discovery of light, signals, or even the faintest hint of life elsewhere would not only be one of the greatest scientific breakthroughs in history, but would also resonate on a deeply human level. It would challenge our assumptions, redefine our place in the cosmos, and open the door to new possibilities for the future of humanity. The search for extraterrestrial life is not just a scientific endeavor. It is a quest that speaks to the very core of who we are and our eternal drive to explore, understand, and connect.